Good day, sir. This is Mhea Sumampong discussing the step-by-step method in non-parametric procedure. So let us start. The first method is to state the null and research hypothesis. We state the hypothesis for performing the test. The two types of hypothesis are null and alternate. The null hypothesis is a statement that indicates no difference exists between conditions, groups, or variables. Alternate hypothesis, also called a research hypothesis, is the statement that predicts a difference or relationship between conditions, groups, or variables. So, in this context, the term null refers to a widely held belief that researchers are working to refute. It doesn't mean that the statement is null, that it means nothing. The null hypothesis, or HO, is the common assumption. It is the total opposite of the alternate hypothesis. The null hypothesis is rejected, nullified, or refuted by the researchers. And a simple tip: if you are asked to convert a word problem, breaking it down into a few tiny steps make it much easier to deal with. A directional or one-tailed hypothesis predicts a statistically significant change in a particular direction. For example, a treatment that predicts an improvement would be directional. So, a directional hypothesis is a researcher's assumption of a positive or negative change, association, or difference between two population variables. This prediction is usually based on previous studies, recognized theories, substantial experience, or relevant literature, while a non-directional or two-tailed hypothesis predicts a statistically significant change, but in particular direction. For example, a researcher may compare two new conditions and predict a difference between them. However, he or she would not predict what condition would show the largest result. So, independent variable will have an influence on the dependent variable in a non-directional hypothesis, but the direction of the effect is not specified. It simply states that a difference will occur. The second method is to set the level of risk or the level of significance associated with the null hypothesis. When we perform a particular statistical test, there is always a chance that our result is due to chance instead of any real difference. Statistical tests assume some level of risk that we called alpha or A. So, when a hypothesis is tested by gathering data and comparing statistics from a sample with a specified value from a theoretical distribution, such as the normal distribution, a researcher determines whether the null hypothesis should be kept or discarded in favor of the research hypothesis. There is also a chance that our statistical results would lead us not to reject the null hypothesis. However, if a real difference actually does exist, then we made a type 2 error. We used the Greek letter beta to represent a type 2 error. So, here's the table stating that the null hypothesis is true or false. After the hypotheses are stated, we choose the level of risk or level of significance associated with the null hypothesis. We use commonly accepted value of A equals 0.05. By using this value, there is a 95% chance that our statistical findings are real and not due to chance. The third method is to choose the appropriate test statistic. We choose a particular type of test statistic based on characteristics of the data. For example, the number of samples or groups should be considered. Some tests are appropriate for 2 samples, while other tests are appropriate for 3 or more samples. So, in hypothesis testing, statistical tests are performed. They can be used to see if a variable has a statistically significant association with an outcome variable, as well as to calculate the difference between 2 or more groups. Measurement scale also plays an important role in choosing an appropriate test statistic. We might select one of the tests for nominal data and a different set for ordinal variables. A common ordinal measure used in social and behavioral science research is the Likert scale. Nana and Sawilowski suggest that non-parametric tests are more appropriate for analysis involving Likert scales. The fourth method is to compute the test statistic. The test statistic or obtained value is a computed value based on the particular test you need. Moreover, the method for determining the obtained value is described in each chapter and varies from test to test. For small samples, we use a procedure specific to a particular statistical test. For larger sample, we approximate our data to normal distribution and calculate a z-score for our data. So the test statistic calculation varies depending on the statistical test performed. The test statistic is usually determined by dividing the patterns in your data. That is the correlation between variables or the difference between groups, by the variance in the data, that is the standard deviation. The fifth method is to determine the value needed for rejection of the null hypothesis using the appropriate table of critical values for the particular statistic. For small samples, we refer to a table of critical values provided in Appendix B. Each table provides a critical value to which we compare a computed test statistic. Finding a critical value using a table may require you to use such data characteristics as the degrees of freedom, number of measurements, and/or number of groups. So what do we mean by the degrees of freedom? The number of independent values that can be estimated by a statistical study is referred to as degrees of freedom. It's also known as the number of possible values while estimating parameters. In addition, you may need the desired level of risk, or alpha. For larger samples, we determine a critical region based on the level of risk or the level of significance associated with the null hypothesis. We will determine if the computed z-score falls within a critical region of the distribution. The sixth method is to compare the obtained value to the critical value. So what do you compare to critical value? A critical value in hypothesis testing is a point on the test distribution that is compared to the test statistic to decide if the null hypothesis should be rejected. You can assert statistical significance and reject the null hypothesis if the absolute value of your test statistic is larger than the critical value. Comparing the obtained value to the critical value allows us to identify a difference or relationship based on a particular level of risk. Once this is accomplished, we can state whether we must reject or must not reject the null hypothesis. While this type of phrasing may seem unusual, the standard practice in research is to state results in terms of the null hypothesis. Some of the tables of critical values are limited to particular sample or group sizes. The seventh method is to interpret the results. We can now give meaning to the numbers and values from our analysis based upon our context. If sample differences were observed, we can comment on the strength of those differences. We can compare observed results to expected results. We might examine a relationship between two variables for its relative strength or search a series of events for patterns. So when it comes to interpreting your data, it's all about determining whether what you discovered supports or contradicts the conclusions of earlier studies in your literature review. Your findings may also provide new information or insights. Last method is reporting the results. It may seem obvious that others cannot use our research unless we communicate our results in a meaningful and comprehensible manner. There is a fair amount of agreement in the research literature for reporting statistical results from parametric tests. Unfortunately, there is less agreement for non-parametric tests. We have attempted to use the more common reporting techniques found in the research literature. And for a good structure and organization of your research, keep in mind these aspects. Start your research results section by restating the purpose of your research so that your readers can refocus on core of your academic article. Include helpful and quality tables, figures, graphs that can synthesize your research. Make sure you include details about your data analysis and interpretation, as well as statistical significance tests. Report the statistical and significant research findings for your academic article's credibility. Use the past tense when describing to your research results. Do not use vague terms and be concise as possible when you are reporting your research findings. And lastly, conclude your section with a short paragraph that summarizes your study's key outcomes. And that is all, sir. Thank you and God bless.